We will now be going over section 4.2 on area. Please make sure you also are copying or writing down or printing out whatever the word notes that go with chapter 4 also, that go over a lot of the properties and such. So in section 4.2, there are a couple of smaller things we're going to go over first, which we will bring together at the end in the next video. The first one we're going to go over are summations, and summations are shown with sigma, or with the big funky E. So when you see sigma, it's the Greek letter, we know we're going to be adding things up. The term on the bottom starts with a variable. It's called the index of summation. It tells you what term you're going to start with, and up top it's going to tell you what term you're going to end with. So this is going to say we're going to go from our second term to our fourth term for a total of 3 terms. And then after that would be your formula. So let's just say it was k squared. So you're going to start with our lower bound, our number at the bottom, which is 2. So 2 squared, increase it by 1, we get 3 squared, increase it by 1, we get 4 squared. So now what the sigma or the summation tells us, we have to add up all of those terms. So 2 squared is 4, 3 squared is 9, 4 squared is 16. When we add these up, we get a total of 29. That is the answer to the summation. So let's do one more of these. If we were to ask to find the sum, k starting at 2 and going to 5, of k times k plus 2. Excuse me. So we're going to start when k is 2. So 2 times 2 plus 2. Then do it over again when k is 3. 3 times k plus 2 plus 4 times, that k should be a 3. We redid it to be a 3. So it's 2 times 2 plus 2 plus 3 times 3 plus 2 plus 4 times 4 plus 2 plus 5 times 5 plus 2. So starting at 2 and ending at 5, we're going to rewrite that whole term. And then we have to do some simplifying of it. So it's going to be 2 times 4 plus 3 times 5 plus 4 times 6 plus 5 times 7. So when we do our multiplications, we're going to get 8 plus 15 plus 24 plus 35. And when we add all of those up, we get 82. So that's the answer to that summation. All right, the other thing, smaller thing that we're going to do in here is going to be summations as the number of things we are adding goes to infinity. The reason why this section is titled area, because I want to know the area between some function and the x-axis, between x equals a and x equals b. Well, if this is not a rectangle, triangle, thing, something of that nature, it is very hard to do. So we're going to do it not by looking at it and trying to find the whole thing. We're going to do it by creating lots of smaller rectangles. So let me get rid of that. And what we're going to do is cut this up into rectangles. Each of them is going to have a top that may be too big or be too small. So it's going to be an approximate area. Well, as the number of rectangles goes to infinity, we're going to get a better and better approximation. So as that number goes to infinity, it will actually become the exact value. Because we cannot add up an infinite amount of rectangles, this is where our limit comes in. So we need to find the value of a limit as the number of the things we're adding goes to infinity. This is how we do it. All right, so if I said find the limit as n goes to infinity of 1 over n squared times n plus 1 all over 2. Should be a 2 in the bottom. The first thing we're going to want to do is get our constants in front of my formula. So I'm going to do the limit as n goes to infinity of 1/2 times n plus 1 over n squared. So what I did was I switched my two denominators. The reason I did that is now my constants are up front. We like taking limits of constants. It is that actual constant. All right, so now that I have this, my next step is to get rid of my parentheses. So I have the limit as n goes to infinity of 1/2 times n squared plus n over n squared. Once you get rid of your parentheses, then we break it up into smaller fractions. So I get the limit as n goes to infinity of 1/2 times n squared over n squared plus n over n squared. Those then both reduce. So I get the limit as n goes to infinity of 1/2 times 1 plus 1 over n. All right, the limit of 1/2 we can do. The limit of 1 we can do. It's the 1 over n we have an issue with. Well, the limit as n goes to infinity of 1 over n would be 1 over 1, then 1 over 10, then 1 over 100. As that denominator goes to infinity, the value of the fraction goes to 0. So we can't actually plug in infinity for n. That's not possible. It's not an actual number. It is a concept. But my fraction that has n in the denominator goes to 0. So this becomes 1/2 times 1 plus 0, which is then just 1/2. And that is the value of the limit. Apologize, I don't really know what happened there. All right, so let's do one more limit. All right, so now we're going to do the limit as n goes to infinity of 81 over n to the 4th times n squared times n plus 1 squared all over 4. So just like in the last problem, the first thing we're going to do is to get our constants out front. I apologize again, it's my first time really working with this. Get our constants out front and my variables inside. So I get the limit as n goes to infinity of 81 over 4 times n squared times n plus 1 squared all over n to the 4th. All right, now that my constants, my 81/4, are out front, I want to get rid of my parentheses over here. So that's going to take me 2 steps. So I'm going to do the limit as n goes to infinity of 81/4 times n squared plus 2n plus 1 all over n to the 4th. All right, I still have to get rid of my parentheses. So I'm going to do the limit as n goes to infinity of 81 over 4. Oh, and I believe I missed a squared up there. It should be n squared. Of n to the 4th plus 2n to the 3rd plus n squared all over n to the 4th. All right. Now that we've done that, I can go ahead and simplify that into 3 smaller fractions. So I get the limit as n goes to infinity of 81/4 times n to the 4th over n to the 4th plus 2n cubed over n to the 4th plus n squared over n to the 4th. And now I can simplify each one of those smaller fractions. And I get the limit as n goes to infinity of 81/4 times 1 plus 2 over n plus 1 over n squared. And as I said before, anything that has an n in the denominator, once it is simplified, the limit as n goes to infinity becomes 0. So this becomes 81/4 times 1 plus 0, which is just then 81/4. That is the answer to the limit as n goes to infinity for this problem. I will do the last part of section 4.2 in the next video.